According to the article, several AFCI brands tend to cause less interference with Powerline home networking. These brands include Cooper, Bussmann, Eaton, Siemens, Westinghouse, and G. Dual function AFCIs, also known as combination AFCIs, combine both arc fault and ground fault protection. These can be more prone to false tripping, especially when used with Powerline devices. For better compatibility, consider using single function AFCIs which provide arc fault protection only. The number of Powerline devices connected to a network can impact interference. Try to limit the number of devices or use high-quality Powerline adapters that minimize noise. Old or damaged wiring can increase the likelihood of interference. Ensure that the wiring is in good condition and meets current electrical codes. Surge protectors can sometimes interfere with Powerline signals. If experiencing issues, try removing surge protectors from the affected outlets. If you are experiencing interference with a Powerline home network due to AFCIs, try the following steps. Firstly, identify the AFCI circuit that is causing the interference. Secondly, replace the existing AFCI with one from a recommended brand. Thirdly, if possible, use single function AFCIs. Fourthly, limit the number of Powerline devices or use high-quality adapters. Fifthly, check the wiring condition and ensure it meets electrical codes. Sixthly, remove surge protectors from affected outlets. AFCIs, or arc fault circuit interrupters, are crucial safety devices designed to protect against electrical fires caused by arc faults. An arc fault is an unintentional electrical discharge that occurs when electricity jumps between two or more conductors. These arcs can generate intense heat capable of igniting nearby flammable materials, leading to a fire. AFCIs are designed to detect these dangerous arc faults and quickly shut off the power to the affected circuit, preventing a fire from starting. Powerline networking, on the other hand, uses a home's existing electrical wiring to transmit data between devices. It works by modulating data signals onto the electrical wires, allowing devices connected to the same electrical system to communicate with each other. Powerline networking can be a convenient way to extend a network without running new Ethernet cables, but it can be susceptible to interference from other electrical devices on the same circuit. The challenge arises because AFCIs are designed to detect and respond to electrical noise, including the high-frequency signals used by Powerline networking. Some AFCIs may misinterpret these Powerline signals as arc faults, leading to nuisance tripping, where the AFCI shuts off the circuit unnecessarily. Several factors can contribute to AFCI interference with Powerline networking. One factor is the design and sensitivity of the AFCI itself. Some AFCIs are more prone to false tripping than others due to differences in their detection algorithms and filtering capabilities. Another factor is the quality and design of the Powerline adapters. Poorly designed adapters may generate more electrical noise, increasing the likelihood of interference with AFCIs. The type of AFCI used can also play a role. Dual-function AFCIs, which combine arc fault and ground fault protection, may be more sensitive to noise and more likely to cause false tripping. Single-function AFCIs, which only provide arc fault protection, may be less prone to interference. The condition of the electrical wiring can also affect Powerline networking and AFCI performance. Old or damaged wiring can introduce noise and impedance, which can degrade Powerline signals and increase the likelihood of interference with AFCIs. Surge protectors, while important for protecting electronic devices from voltage spikes, can also sometimes interfere with Powerline signals. Some surge protectors may filter out high-frequency signals, which can weaken the Powerline signal and reduce network performance. There are several strategies you can use to minimize AFCI interference with Powerline networking. Firstly, consider using AFCIs from brands that are known to be less prone to interference. Some manufacturers have designed their AFCIs to be more tolerant of Powerline signals, reducing the likelihood of false tripping. Secondly, use high-quality Powerline adapters that are designed to minimize noise. Look for adapters that comply with industry standards such as HomePlug AV or G. HN, and that have been tested for compatibility with AFCIs. Thirdly, use single-function AFCIs instead of dual-function AFCIs, if possible. Single-function AFCIs may be less sensitive to noise and less likely to cause false tripping. Fourthly, ensure that the electrical wiring is in good condition. Have a qualified electrician inspect the wiring for any signs of damage or wear and tear. Repair or replace any damaged wiring to reduce noise and improve powerline signal quality. Fifthly, try removing surge protectors from the affected outlets. If you suspect that a surge protector is interfering with powerline signals, try plugging the powerline adapter directly into the outlet to see if that resolves the issue. Sixthly, limit the number of powerline devices on the same circuit. The more devices that are transmitting data over the electrical wiring, the more noise there will be, which can increase the likelihood of interference with AFCIs. Seventhly, try using different outlets for the powerline adapters. Sometimes, moving the adapters to different outlets on the same circuit can reduce interference. Eighthly, consider using a dedicated circuit for powerline networking. If you have a spare circuit in your electrical panel, you can dedicate it to powerline networking. This can help to isolate the powerline signals from other electrical devices, reducing the likelihood of interference. Ninthly, install a line filter. A line filter is a device that is designed to block noise and interference from electrical wiring. You can install a line filter on the circuit that is used for powerline networking to reduce interference with AFCIs. Tenthly, use a different networking technology. If you are unable to resolve the AFCI interference with powerline networking, you may want to consider using a different networking technology such as Ethernet or Wi-Fi. These technologies do not rely on electrical wiring to transmit data and are not susceptible to interference from AFCIs. Understanding AFCIs, arc fault circuit interrupters, and powerline networking. AFCIs are critical safety devices designed to protect against electrical fires caused by arc faults. An arc fault is an unintentional electrical discharge that occurs when electricity jumps between two or more conductors. These arcs generate intense heat, igniting flammable materials, leading to a fire. AFCIs detect these dangerous arc faults and quickly shut off power to the affected circuit, preventing fires. Powerline networking uses a home's existing electrical wiring to transmit data between devices. It modulates data signals onto the electrical wires, allowing devices connected to the same electrical system to communicate. It's convenient for extending a network without running new Ethernet cables, but is susceptible to interference from other electrical devices on the same circuit. The challenge arises because AFCIs are designed to detect and respond to electrical noise, including the high-frequency signals used by powerline networking. Some AFCIs may misinterpret powerline signals as arc faults, leading to nuisance tripping, where the AFCI shuts off the circuit unnecessarily. Factors influencing interference. The design and sensitivity of the AFCI are critical. Some AFCIs are more prone to false tripping due to differences in detection algorithms and filtering capabilities. The quality and design of powerline adapters also play a role. Poorly designed adapters may generate more electrical noise, increasing the likelihood of interference with AFCIs. The type of AFCI used matters. Dual-function AFCIs, combining arc fault and ground fault protection, may be more sensitive to noise and more likely to cause false tripping. Single-function AFCIs, providing only arc fault protection, may be less prone to interference. The condition of electrical wiring is important. Old or damaged wiring can introduce noise and impedance, degrading powerline signals and increasing the likelihood of interference with AFCIs. Surge protectors protect electronic devices from voltage spikes but sometimes interfere with powerline signals. Some surge protectors may filter out high-frequency signals, weakening the powerline signal and reducing network performance. Strategies to minimize interference. Firstly, use AFCIs from brands known to be less prone to interference. Some manufacturers design their AFCIs to be more tolerant of powerline signals, reducing false tripping. Secondly, use high-quality powerline adapters designed to minimize noise. Look for adapters that comply with industry standards like Home Plug AV or GHN and are tested for AFCI compatibility. Thirdly, if possible, use single-function AFCIs instead of dual-function ones, as they may be less sensitive to noise. Fourthly, ensure electrical wiring is in good condition. Have a qualified electrician inspect the wiring for damage or wear and tear, and repair or replace damaged wiring to reduce noise and improve power line signal quality. Fifthly, try removing surge protectors from affected outlets. If you suspect a surge protector is interfering, plug the power line adapter directly into the outlet to see if that resolves the issue. Sixthly, limit the number of power line devices on the same circuit. More devices transmitting data over the electrical wiring increase noise and the likelihood of AFCI interference. Seventhly, try using different outlets for power line adapters, as moving adapters to different outlets on the same circuit can reduce interference. Eighthly, consider using a dedicated circuit for power line networking. If you have a spare circuit in your electrical panel, dedicate it to power line networking to isolate power line signals from other electrical devices, reducing interference. Ninthly, install a line filter designed to block noise and interference from electrical wiring on the circuit used for power line networking to reduce interference with AFCIs. Tenthly, use a different networking technology. If you cannot resolve AFCI interference with power line networking, consider Ethernet or Wi-Fi, which do not rely on electrical wiring and are not susceptible to AFCI interference. Additional tips. Consider the frequency of the power line devices. Near power line adapters operate on different frequencies, potentially reducing interference with AFCIs. Experiment with different channels or frequencies within the power line adapter settings. Contact the manufacturers of both the AFCI and power line adapters. They may have specific recommendations or firmware updates to improve compatibility. Proper grounding is essential for electrical safety and can help reduce noise and interference. Ensure that the electrical system is properly grounded according to electrical codes. Use shielded Ethernet cables for connections between power line adapters and devices to minimize the radiation of noise. If you live in an apartment or shared building, interference from neighboring units' electrical systems may be a factor. In such cases, coordinating with neighbors or the building management may be necessary. Note that electrical codes vary by location, so it's essential to comply with local regulations. If you are unsure about electrical work, consult a qualified electrician for assistance. If you continue to experience nuisance tripping with AFCIs, it's essential to investigate the cause thoroughly. This may involve testing the circuit for actual arc faults or consulting with an electrician to diagnose the problem. It's important to ensure that the electrical system is safe and functioning correctly. If the problem is due to outdated wiring or electrical issues in the home, consider upgrading the electrical panel and wiring to meet current standards. This can improve electrical safety and reduce the likelihood of interference. Be cautious when making changes to electrical systems and always follow safety precautions. If you are not comfortable working with electricity, it's best to leave the work to a professional. Troubleshooting steps. If you are experiencing interference issues, a systematic approach to troubleshooting can help identify the cause and implement the appropriate solutions. First, identify which AFCI is causing the interference. If you have multiple AFCIs in your home, determine which one is tripping when power line devices are in use. Second, test power line adapters in different outlets. Try plugging the power line adapters into different outlets on the same circuit to see if the interference is reduced. Third, isolate devices. Disconnect other electrical devices from the affected circuit to see if the interference is caused by a specific device. Fourth, update firmware. Check for firmware updates for both the AFCI and power line adapters and install the latest versions. Fifth, adjust AFCI settings. Some AFCIs have adjustable sensitivity settings. Consult the manufacturer's instructions to see if adjusting the sensitivity can reduce nuisance tripping. Sixth, use a line filter. Install a line filter on the affected circuit to block noise and interference. Seventh, consult an electrician. If you are unable to resolve the interference issues, consult a qualified electrician for further assistance. It is also essential to consider future planning and upgrades. If you are planning to install new electrical circuits or upgrade existing ones, consider the potential impact on power line networking. Use high-quality wiring and follow electrical codes to minimize the risk of interference. When choosing Powerline adapters, consider the features and specifications. Look for adapters that support advanced features like multiple input, multiple output, quality of service, and power-saving modes. Regularly inspect and maintain electrical wiring and components. This can help identify and address potential issues before they cause interference or safety hazards. Remember, electrical work can be dangerous, so always follow safety precautions and consult a qualified electrician if you are unsure about any aspect of the work. This discussion about arc fault circuit interrupters and powerline networking illustrates the complexities of modern electrical systems and the importance of understanding how different devices and technologies can interact with each other. By following the strategies and tips outlined above, you can minimize interference and ensure that both your electrical system and network operate safely and reliably. It is important to consult with qualified professionals when dealing with electrical issues or making changes to electrical systems.